Again, I'm not sure why I'm doing this, but okay, lesson 10. We're going to talk about lesson 9 was your lab, of course. So lesson 10, we're going to just talk about signs of chemical change. Tomorrow, we're going to talk about lesson 11, balancing chemical reactions. Yay! And then we're going to learn how to write them. Yes? Okay. So a chemical change occurs when one or more new substances are formed, basically. So when you combine a couple things together and we get something that's formed. Okay, make sure you know that. Okay, chemical change when you get basically to form new substances. Okay, physical change is when no new compounds are formed, nothing new is formed. Okay, a new compound is not formed. Physical changes include phase states, for example, changes in states. So gases, liquids, solids kind of thing. That's a physical change. So if you took ice and melted it to a liquid, that's a physical change. All right. We can look for whether evidence has been a chemical change or a physical change. Observing one of these signs does not guarantee that chemical change has occurred. For example, boiling water requires energy, but this is a physical change. Five things that tell you basically a physical or a chemical change has taken place. I can't talk yet this morning. Odor change is one. Okay, so if you smell something, basically an odor, that is a good indication that a chemical change has taken place. Color change, so maybe perhaps a different color is formed. Okay, formation of a gas in a solution. I think you have all this, correct? You're just and formation of a solid called a precipitate. And remember, this we've talked about already this year, yes? Precipitate. When did we talk about that? When was that? Yep. Solubility, right? So if you get something in the bottom row there, okay, you're mixing some stuff together and all of a sudden something happens in the bottom row and you get a solid, that's an indication that a chemical change has taken place, okay? And energy change, of course. If something gets very hot or something gets very cold, that's a good indication that a chemical change has taken place. Okay. Exothermic and endothermic reactions. You probably remember these from last year, correct? I think. Exothermic means what? We give off energy. Yes. So that would be like, for example, burning propane. It would be giving off energy. That's a chemical, or that's a exothermic reaction. Okay. Endothermic is basically something that takes in energy, like a cold pack, for example. If you put ammonium nitrate, which was one of your compounds, into water, okay, it should get kind of cold. That is an example of an endothermic reaction. Okay. Good? Yeah? All right. State whether the following is an endothermic or exothermic process. What is the melting of ice? Do you need to put energy in or get energy out for that to happen? Melting of ice. Yep. Energy in, so that is endothermic. You're going to put down endothermic there. I'm not going to write those down because this is not really the right program for that, but endothermic, yes? Energy has to go in order to melt the ice. Okay, that's how we're melting it. Photosynthesis. Oh, that's unit 2. Photosynthesis, energy in or energy out? What do you think? I can see how this one could go either way, but there's only one right answer. Yeah, exactly. So it's endothermic again. Where does that energy come from? Yeah. Yeah. What? The sun. Okay. So endothermic. Respiration. So cellular respiration, opposite. Yep. Yeah, exothermic. Okay. We're going to talk about cellular respiration in unit 2. All right. So reaction that occurs inside a car engine. Okay. Does that make energy or take energy in, or is that exothermic giving off energy? Yes. It's not somebody else. Anyone else? Car engine. In or out? Takes energy in? Yeah. Okay. Yeah. I would say most people there would say that their argument is, well, gasoline, for example, that'd be like energy in kind of thing. But this is the reaction that occurs inside a car engine, so I'd say exothermic in this case, okay? Because basically that heat is being transferred into motion, right? So heat is a byproduct. That's why we have radiators and stuff like that. Charging a battery, putting energy in or taking energy out? What do you think, Ben? Yeah, endothermic for sure. Yeah. Okay. Once we disconnect the battery charger then, and we hook it up to a trailer or something like that, that'd be exo, right? Giving energy off. Okay. All right. Good. You do have 3 examples there, I guess, or 3 questions you guys can do. If you want to do those right now, you go ahead. I'm going to walk around. We'll check homework as we're doing that, and then I'll put the answers up here. Okay.